Hi guys, welcome back to Nerd Talk. I am really excited to have you here, so sit back, relax, and get ready for our 15th journey together. In this video, we'll uncover the untold story of wartime computing, from the chaos of World War II and the mystery of the Enigma machine, to the secret codebreakers of Bletchley Park, the revolutionary Colossus computer, and the birth of ENIAC. This is the hidden technological race that laid the foundation for the modern digital world. World War II changes technology forever. By the late 1930s, the world stood on the edge of chaos. Across Europe, nations expanded armies, built warplanes, and prepared for a conflict unlike anything humanity had seen before. But hidden behind the tanks and battleships was another battlefield: information. Military leaders depended on communication, calculations, and intelligence to coordinate millions of soldiers across continents. As World War II erupted, governments realized that speed mattered more than ever. Artillery calculations, navigation systems, weather predictions, and encrypted communications all required enormous amounts of computation. Human mathematicians alone could no longer keep up. The pressure of war began pushing science and engineering toward a revolutionary new idea: machines that could think through calculations faster than humans. The race for faster computation. Every battle produced mountains of numbers. Military analysts calculated artillery trajectories using wind speed, distance, gravity, and terrain elevation. Naval commanders tracked submarines across oceans, while pilots relied on complex navigation data during dangerous bombing missions. At the same time, nations competed technologically to gain advantages over their enemies. Whoever could process information faster could react faster on the battlefield. This urgent race for computation unknowingly accelerated the birth of modern computing technology. Germany's secret weapon, Enigma. To protect military secrets, Nazi Germany relied on an advanced encryption machine called Enigma. At first glance, it resembled a simple typewriter locked inside a wooden box. But inside, Enigma transformed ordinary messages into coded text that appeared completely meaningless to enemy listeners. German commanders used Enigma to coordinate submarine attacks, troop movements, and military operations across Europe. They believed the machine was impossible to crack. For the Allies, intercepting these coded messages became one of the greatest intelligence challenges of the war. The mystery inside Enigma. The true complexity of Enigma came from its rotating wheels, called rotors. Every time a key was pressed, the internal wiring shifted positions, changing the encryption pattern instantly. Even the same word typed twice would appear completely different. To make things even harder, German operators changed settings every single day using secret codebooks. Millions of combinations became possible. Breaking Enigma by hand was nearly impossible. And yet, Allied codebreakers knew the fate of countless lives depended on solving it. Alan Turing enters the war. Among the brilliant minds recruited by British intelligence was Alan Turing, a young mathematician already known for revolutionary ideas about computation and logic. During the war, he joined Britain's secret code-breaking operations. Turing believed machines could systematically solve logical problems far faster than humans. Using mathematics, pattern analysis, and automation, he helped create methods capable of attacking the enormous complexity of Enigma encryption. Bletchley Park. Far away from the battlefields of Europe, hidden within the quiet English countryside, stood a place that would secretly shape the outcome of World War II: Bletchley Park. To ordinary citizens, it appeared to be just another countryside estate. But behind its walls, one of the greatest intelligence operations in human history was unfolding in complete secrecy. The British government transformed Bletchley Park into the headquarters of wartime codebreaking. Thousands of people were recruited from across the country: mathematicians, engineers, linguists, chess champions, crossword puzzle experts, and radio operators. They worked day and night inside crowded wooden huts filled with maps, intercepted messages, and machines constantly humming with activity. Every hour, radio operators intercepted encrypted German transmissions traveling invisibly through the air across Europe and the Atlantic Ocean. These coded messages contain vital military information about submarine attacks, troop movements, and strategic operations. The race to decode them became a desperate battle against time. The intelligence produced at Bletchley Park helped Allied forces reroute supply convoys away from German submarines, predict enemy movements, and prepare defenses before attacks occurred. Historians later estimated that the work done here may have shortened World War II by several years and saved millions of lives. Machines that could break codes. The Enigma machine produced millions of possible code combinations, making manual decoding nearly impossible. Human codebreakers could spend weeks trying to solve a single configuration, while German military settings changed every single day. The Allies needed a faster solution. To overcome this challenge, British engineers and mathematicians designed powerful electromechanical devices capable of automatically testing thousands of code possibilities. These machines became known as the Bombay machines. Instead of relying entirely on human guesswork, the Bombays systematically eliminated incorrect combinations at incredible speed. Rows of rotating drums spun continuously, while electrical circuits searched for logical patterns hidden within encrypted messages. The machines did not understand language the way humans did, but they could process logical possibilities far faster than any person ever could. For the first time in history, machines were being used not just for arithmetic calculations, but for solving complex logical problems. This moment marked one of the earliest true steps toward modern computing and artificial intelligence. The Lorenz cipher. Although Enigma protected many German military messages, the Nazi high command relied on an even more advanced encryption system, known as the Lorenz cipher. Unlike Enigma, which was used widely across the military, Lorenz carried extremely sensitive communications between Germany's top generals and commanders. The Lorenz system was vastly more complicated than Enigma. Its transmissions contained strategic military plans, battlefield updates, and high-level wartime decisions. If Allied intelligence could break Lorenz encryption, they would gain access to some of the most secret information in the entire German war machine. But decoding Lorenz presented an enormous challenge. The encryption patterns were so complex that even the Bombay machines struggled against them. Allied cryptanalysts realized that defeating Lorenz would require something entirely new, an electronic machine unlike anything ever built before. This challenge pushed engineers toward a technological breakthrough that would permanently change the future of computing forever. Colossus, the secret electronic giant. To attack the Lorenz cipher, British engineer Tommy Flowers proposed building a revolutionary electronic machine called Colossus. At the time, many experts doubted his idea because electronic systems using thousands of vacuum tubes were considered unreliable and unstable. Ignoring skepticism, Tommy Flowers and his team pushed forward in complete secrecy. In 1943, Colossus became operational at Bletchley Park. Towering racks filled with glowing vacuum tubes stretched across entire rooms, creating an electronic machine unlike anything the world had ever seen before. Colossus rapidly analyzed encrypted messages by reading punched paper tapes at extremely high speeds. Electronic circuits searched for hidden patterns and probable cipher settings far faster than any human team could achieve manually. What once required weeks of exhausting work could now be completed within hours. Colossus gave Allied intelligence a major advantage during the final years of World War II and became one of the earliest programmable electronic digital computers in history. The power of electronic computing. Earlier computing systems relied heavily on moving mechanical components, such as gears, switches, and rotating drums. These systems were powerful for their time, but mechanical movement limited their speed and reliability. Colossus changed everything by relying primarily on electronic circuits. Instead of waiting for mechanical parts to move physically, electrical signals traveled almost instantly through vacuum tubes. This dramatically increased the speed of information processing. Punched paper tapes carrying encrypted German messages raced through the machine continuously, while circuits performed logical analysis at incredible speed. Operators watched as the glowing machine processed information faster than anything previously imagined. Colossus demonstrated the enormous potential of electronic computation. It proved that machines could process complex information rapidly and reliably, laying the technological foundations for the modern computer age. A computer hidden from history. When World War II finally ended, the British government treated Colossus as one of its most guarded secrets. The existence of the machine remained classified because intelligence agencies feared other nations could learn from its technology. Many Colossus machines were dismantled and destroyed shortly after the war. Engineers, operators, and cryptanalysts who had worked on the project were ordered never to discuss what they had built. For decades, silence surrounded one of the greatest technological achievements of the 20th century. Because Colossus remained hidden, much of early computing history focused instead on later American machines like ENIAC. The world remained unaware that programmable electronic digital computers had already existed secretly during the war years. Only decades later did historians fully uncover the truth about Colossus and the extraordinary people behind it. What was once hidden in secrecy finally earned recognition as one of the true beginnings of modern electronic computing. America builds ENIAC. While British scientists secretly fought Germany's encrypted communication systems, the United States faced a different challenge during World War II. The American military needed enormous numbers of ballistic calculations for artillery weapons. Every shell fired from a cannon required precise mathematical tables that considered distance, gravity, wind speed, air pressure, and projectile weight. At first, these calculations were performed manually by teams of human mathematicians, many of them women working tirelessly for long hours. But as the war intensified, the amount of required computation became overwhelming. Military planners needed a faster solution, capable of processing calculations at unprecedented speed. To solve this problem, engineers John Mauchly and J. Presper Eckert began designing a revolutionary machine at the University of Pennsylvania. Their goal was ambitious: to create a fully electronic computer capable of performing calculations thousands of times faster than humans. This machine became known as ENIAC, short for Electronic Numerical Integrator and Computer. Unlike earlier electromechanical systems, ENIAC relied almost entirely on electronics. It marked the beginning of a new era in computational history. Thanks a lot for watching. If you are liking the videos, please do like, share, and subscribe.